Hi, I'm Cameron. This is Seth. Welcome to our plant. Let's take a tour.
Hi there, welcome back to the channel. We're here at Anacortes Municipal Water Plant to check how they make fresh water and pipe it off to the city. So this is going to be an interesting video, so stay with us. And we're going to spend some time talking to the folks here inside about, how people can become a water plant operator. This state has a big shortage of qualified water plant people. Anyway, thanks for watching. Welcome everybody. We're here with, and I'll let them introduce themselves, but these are two operators here at the Anacortes water plant, and we're going to ask them a few questions on how, if somebody was interested in working in this field, how they could get into it. So anyway, go ahead and introduce yourselves.
All right, well, I am Cameron. I'm Garth's son, actually. I've been here at the water plant now. I've been here the longest of all the operators. I've been here for about 7.5 years. I'm a level 3 operator, and I actually just scheduled my level 4 test for next week. And level 4 is the top certification level here in the state of Washington. It's a WTPO 1 through 4, and that stands for Water Treatment Plant Operator.
My name's Seth. I'm also an operator here at the Anacortes Water Treatment Plant. I'm a level 3 operator. Recently just got my certification level up to that level 3 recently. I've been working here for, just about 4 years now. I started as a seasonal here for the 3 years prior to that. And, yeah.
Okay.
We're now going to tour the chemical building, and the first thing that we're going to do in the chemical building is go into the dry chemical room. Now this is not really in a particular point in our process, but this is where we house all our different chemicals that we use in the process, and they're fed from here. So let's go ahead and take a tour inside. This is our dry chemical room. This is where we keep chemicals such as filter aid polymer, coag polymer, microsand. We used to use soda ash for our process. We no longer use that. We even store softener salt in here that we use not only for the water softener if needed, which we've never used it.
Never know.
Or in the wintertime when the sidewalks all ice up. First, I'm going to show you the filter aid polymer system, and that's this direction over here. We have 2 of them, and you will notice in this video that we have 2 of most things for redundancy. These are our filter aid polymer preparation systems, and so polymer is basically like a glue, and at certain times of the year we'll feed it to our filters in order to aid with their performance. And it comes in these bags here in powdered form, and then we add water, and then it turns into a consistency of kind of a light slime, if you will. Come this way and I'll show you what it looks like before we add water. This is powdered filter aid polymer. And then in this tank we add water. The upper tank is the mixed tank, and then the lower tank is the actual feed tank. We swap back and forth between these 2 systems every month, and then the system that we've turned off, we then clean. Next, once we're done with this, next we'll go and we'll look at the coag poly system. Do you want to explain that one too?
Yeah, sure.
So we're going to go down in the pit down here where the rest of the systems are.
So these bags right up top here, these are full of what we call coag poly or coagulant polymer. It's basically a similar kind of thing to the filter aid polymer. We just added at a different stage of the treatment process. It aids in the flocculation process, and we'll get into that more in the other treatment sections. So we'll go down into the preparation area.
Please excuse the extension cord. Our instrument tech Kent is working on one of his jobs today. He's calibrating flow meters today. Go ahead.
All right, so we have our coagulant polymer batching system. So it runs essentially the same way as our filter aid polymers. So the dry polymer is dropped into this hopper here, and then using air is brought up into the mix tank where it's mixed with water for a certain period of time. and then it drops down into this lower tank where it feeds into our treatment process.
I should note that I mentioned that the filter aid polymer, we're now only doing part of the year. Usually we don't find it necessary anymore during the summer. This we have to have on at all times, or else if we don't have this polymer to act as a glue around the particles that settle out, then our process just falls apart. It doesn't work.
Definitely one of the most essential chemicals that we use in our treatment process.
Definitely.
Yep. So if you come on through this way, we got some pumps that distribute these chemicals to various locations throughout the treatment process. So these blue pumps is what is pumping this coagulant polymer into our trains and aiding in flocculation. And then further on into these yellow pumps, these two here for the filter aid polymer, and those go in after clarification and then into the filters. And then these pumps we've had offline for quite a while. We don't use them ever. They're for soda ash mixture for control of alkalinity, but the alkalinity within our treatment process is consistent enough that we never have to use it, but we have it just in case.
And let's also mention the sand system here. This is the sand feed system. So in our train we use, in our process we use a special kind of sand that is ballast, and then with our, as you'll see later on, we'll show you, with our chemical process, we use microelectricity, like microcharges that attract the particles, the solids in the water together, and they bond with the sand, and then we put the polymer around them as a glue. So periodically we lose the sand. Our system's designed that we can reuse the sand over and over and over and over again, but over time we'll lose a little bit, and so periodically we got to add more sand to our trains, our processes, and so that's where this one comes in. This one we can choose which train we're going to add sand to and how much, and so a whole bag is 3,000 pounds?
I believe so.
Yeah, one of these whole sacks is 3,000 pounds, so we can theoretically add as much or as little as we want. And so that's where this comes in. And then the soda ash system that you had filmed previously, we've had this system offline and empty for the last several years. When this plant was first built, we used soda ash in case we had a really dirty river and we were losing our alkalinity in our water, and it would help boost up not only the pH but also the alkalinity. Because when the water gets to a certain point where it's no longer alkaline, the process just doesn't work as well. We got to have a certain amount of alkalinity and hardness in our raw water in order for our process to work. I think that pretty much does it for the dry chem room. Let's go ahead and move to the wet chem room.
Why don't you describe to us what are the different levels?
Sure. We could start with the entry-level position. So as Seth said, we do a program every summer where we have a seasonal temporary employee. And mostly what they'll do is maintenance and landscaping, running the mower, doing weed eating and all that. But then, they'll do cleaning, and sometimes they shadow maintenance people here at the water plant, kind of learn what we do. And I think it's a really good program because we have a long track record of hiring our seasonal labor and then eventually they grow into really good operators. And we've got several examples here. One of our supervisors was a seasonal many years ago. Now he's maintenance supervisor. Seth did it for 3 summers, and then he got hired on during his 3rd summer as an operator, and he's turned into one of our best operators. And then I myself, I was a seasonal in 2014, and then I came back 3 years later and got hired in 2017, and I've been here ever since. One of our maintenance guys, Torin, he was a seasonal, and then he got hired on as a maintenance person. So, that's really the basic, like the first entry-level position, and it's kind of hard to say that it's an entry-level position because it's not guaranteed that you'll get a permanent job, but it is worth noting because we do have a long track record of hiring those employees because they get their foot in the door. But the actual, and I've got notes here to answer the questions, the actual formal entry-level position is called an OIT, an operator in training, and that would be entry-level. And then there's the expectation with the OITs that they get at least a level 1 certification within a year. There's just that expectation there.
Is that kind of the same for other municipalities? They same expectations?
Generally, yeah. It's hard to say because, and a lot of what I'll talk about and what Seth will talk about with these questions, it really depends on municipality and also the water system and the plant itself, because everybody's got different policies, everybody does things differently. But for us, OIT is the entry level position, and then the different positions are based on your certification. So, like I said when I introduced myself. In Washington State, there's 4 levels of certification for water treatment plant operator. There's 1, 2, 3, and 4. In other states, like California, for example, California's got 5 levels. And then there's also on the other side of things, and that's not us per se, but on the other side of things, there's the water distribution manager certifications as well. And that more has to do with the water system itself, like residential connections, water mains, valves, things of that nature. And then another position that we have here, and hopefully we'll get a chance to talk to him later, is instrument tech. And his name's Kent. And he got hired on the same day I did. And he has a different role because he doesn't touch into the operations. He more handles pumps and instruments and does verifications, and he does pressure gauges and readouts and their relationship.
All sorts of stuff. Oh yeah.
All sorts of stuff, yeah. And then their relationship with our control system that we use, our control software that's called SCADA. And if you know anything about a process environment like this, or like a refinery or any sort of factory, SCADA is pretty well an industry standard for an operating system. And then after that, once you get above an operator, then there's supervisory positions, and eventually the top level here is the water system manager, and then he oversees not just the water treatment plant but also the distribution system. So he balances his time between the 2 departments. And that's, for us anyway, that's pretty much it for the different positions.
Okay.
I'd like to add a little more about the entry level stuff.
Sure.
There's a lot of different avenues that you can take to get to those entry points. So I was going to school out at Washington State University in Pullman, and the seasonal position here was a great opportunity for me to work during the summers and then go back to school during the rest of the year. And it just so happened to work out that I was interested in this sort of subject, and then these guys kind of talked me into applying for the job.
And by these guys, he means me.
Yeah, pretty much. Yeah. But yeah, so there's a lot of different ways to get into these sort of positions. You don't have to grow up dreaming of being an operator your entire life, or you can just...
I certainly didn't.
Right? But then you can you just run into people who know the positions and what they're like, and they get you into it, and you can go from... I was going through college education. You don't have to have any of that. You can just start working as a seasonal. Or,
it's helpful, but you don't have to have it.
Right.
Yeah.
Or maybe you've figured out how to get certified before you're even hired, and you go and take those exams and get certified, and then of course you're a lot more hireable that way. There's also a lot of tech programs that are out there. I know one of the more local ones for us is Bellingham Technical College up in Bellingham. They have a lot of operator schools going on there that you can learn a lot about the processes, and maybe not necessarily get certified through that program, but have a better understanding of how to get that certification and have some previous knowledge and education that's pretty desirable in a hiring process. So a lot of different avenues to getting into that entry-level position.
All right.
Well said.
Cool.
The wet chemical room. The name is because these are all liquid chemicals. We've got it divided into 2 sides. So here on this left side, this is where we store our sodium hydroxide, or for short, we just call it caustic. That's a very basic chemical. We use that for alkalinity and pH control. Most of the year, we're ending up just putting it into our finished water for control of pH and control pH within the water in the distribution system, so it's not corrosive. We do turn it on periodically during dirty river events, in order, as Cameron said before, to kind of keep that pH and alkalinity balance right where we need it to be in order to get the optimal clarification. And then on the other half of the building, we have alum for short, or aluminum sulfate. This is an acid, and this is our primary coagulant that we use to destabilize particles in the water and have them able to actually meet and connect and then form bigger floc that then settle out of the water. And as you can see on each manifold here, within each side of the building. We've got different, pardon me, we've got different dosing pumps that send it to different locations throughout the process. So we've got a few here that send the caustic to the front of our trains, which we will have shown you there. And then we have a few of these pumps that can send them to the HSPS, or high service pump station. And that's where we're mainly dosing it throughout the year to have control over the pH of our finished water.
And then these big red pumps here are transfer pumps. So the way we operate is we'll keep most of the chemical in these bulk tanks, and then we have these smaller day tanks. And so what we'll do is we'll transfer periodically when the level gets low. We'll transfer chemical to fill up the day tank, and that's where these two red pumps come in. Is they're the transfer pumps. And then down here, just to mirror what Seth was saying, down here is our feed pumps for our alum. These two go to our main process, our bass train. This one's train 2, this one's train 1. We have a spare here, and then these two, we only do one at a time, just again for redundancy, but this sends a little bit more alum, a second smaller dose, to the filters in order to aid the filtration process. With that, next we're going to move on to the sodium hypochlorite feed room.
And now we are at our sodium hypochlorite feed building. It's basically our source of chlorine. All right, let's take a walk in.
All right. So originally when this plant was built and came online in 2013, for several years we used to employ chlorine gas that we had in 1-ton cylinders, and then we would feed the chlorine gas. Don't get me wrong, chlorine gas is a pretty simple system and a pretty reliable system, but the problem is if you may know, it's very toxic. And so if there is a leak, we would have to suit up with the whole self-contained breathing apparatus, and then every time we change out a tank, we'd have to put those on just in case. And so in 2018, 19, somewhere around there, we took that system out, we replaced it with the sodium hypochlorite, which basically is like an industrial grade bleach. And in water plants, there's two ways to do it. Some plants, they'll have on-site generation where they'll make their own sodium hypochlorite. In our case, we found it was much more cost-effective and much more economical if we get it delivered. So we've got a supplier that brings in a semi-truck, and then we fill it. And we have the two tanks, once again, like we mentioned, for redundancy. And then we don't have a day tank on this, but we do have this big pump. This is the transfer pump. So sometimes we want to move the liquid from one tank to another, or in the case today of tank 1 here, we want to get the remainder out, make sure that it's empty, so we've got plenty of room to take a delivery. And then we've got our feed pumps here, we got flow meters, and over here, this is part of the feed process. There's the actual chlorination going through these valves, and then we are able to regulate our feed flow through here.
So basically how this manifold works is your sodium hypochlorite, or bleach, is injected into a water system right at this location. And so that makes it so you can send bleach in water to a location instead of just a full line of bleach all the way out to different locations throughout the plant. So it adds a little safety factor. It helps with the mixing of the chlorine into the water, make sure everything's all mixed up, and it helps us meter it and make sure we're dosing it accurately and precisely. So
water comes in from the process into this manifold, and you inject bleach into it and then send it back out into the process.
Quick caveat is this is actually our finished product water, so if you wanted to drink the water that's coming into this system, you absolutely could. It's fully potable. So we take potable water, add chlorine dose to it, and then inject it into parts of our process to make sure that disinfection is happening.
In cases like this, and also with the rest of the chemicals that we've seen thus far, we use it at what we call carrier water. So we have a supply of water, the finished water coming through, and then we add the chemical to it. And then that allows it to carry to our process.
That's sodium hypochlorite.
Okay, so let's say I started here. I'm an entry-level trainee. What's my typical day like?
You want to take that one?
Yeah, sure. So there's a lot of it is learning through fire hose. So you're gonna have to learn a lot of new information every
And
single,
also using a fire hose.
and also
sometimes,
using
too.
a fire hose,
Yeah.
literally, right? Every single water treatment plant is different from the other, so every process is going to be different. Every process within that process is going to be different, and you have to learn those little intricacies and able to run all of those systems in one continuous system. So for us here, a lot of that entail like your first 3 months that you're working, you're shadowing an operator with a level 3 or level 4 certification, because they've shown that they already know how to operate the water treatment plant. They have the certification to do so. And so a lot of that is going to be shadowing. And then there's also, aside from shadowing, they'll kind of babysit you through certain processes that you're learning. So they'll help you along, backwash a filter, turn one of the processes on and off, something like that. But you're always going to have those other experts guiding you through that process. So you're getting a lot of hands-on training doing the operations work, but you're going to be guided with an expert the entire way. So yeah, a lot of the entry-level positions end up doing pretty much operator work, but just under direct supervision.
A lot of maintenance involved too. I mean, just like the seasonal position, you're going to start out with doing a lot of maintenance. So a lot of our monthly tasks that reappear. A lot of cleaning and a lot of changing oil and equipment, and we do some big jobs, like for example, a lot of our entry-level people will send them over to the intake on the other side of the river, and they'll go down in the intake chambers once or twice a year and clean all that out. And it's a dirty job, but it's a really necessary job. And so with our trainees, our entry-level people, we like to make sure that they get the experiences of even the hard jobs.
So a little bit of a mechanical aptitude is probably a good thing, huh?
Oh yeah.
It's not required, but it's helpful.
Mhm.
It's definitely helpful. Yes.
Okay.
So another addition to that is when trainees are going through those maintenance processes, you learn a lot more in-depth information about your specific system. So there's little gremlins that pop up, little issues with different equipment that happen no matter where you're at. And if you're doing maintenance on all of those little systems throughout your entire system, you have a much deeper understanding of how the whole thing runs. And gaining that deeper understanding definitely helps you advance further and run the whole treatment plant better.
Yeah.
So,
Mm-hmm. Definitely.
Okay.
Right, so step 1 of our treatment process is actually the intake building across the river right over there. And so what's happening over there is there's the river water's flowing by, and it flows into the intake chambers, which are towards the bottom of that river channel. And the intake pumps basically pull that water up, send it through a 36-inch pipe underneath the river, and then across over to our treatment plant over here. And the reason we have the intake building on the other side, as Cameron Fraser may have said earlier, is that that's where the deepest part of the channel is. Flood risk is, the flood events are more likely to happen on the outside of the bend of the river, and keeping our treatment process safe, we can always add an intake pump and vamp stuff like that. That damage over there is a little bit more mitigated if we keep it over on that side. So here, pretty much at step 2 of our process, this is the Zeta sizer. This is one of our many analyzers we have throughout the water treatment plant. This has become a really important piece of equipment for us, because what it can do is it can basically measure the level of stickiness of all the particles that are floating around in the water. And it's sort of an abstract measurement, but it gives us a good idea of the availability of these particles to be able to collide, stick, and form bigger floc that then settle out of the water more effectively. And so this has been really important for us to be able to navigate different chemical changes at different times of the year, how much chemical we should be putting in, and it's really increased our efficiency of the water treatment plant. So we're using a lot less chemical than we used to. We're treating the water in better ways, so we get higher quality water at the end of our clarification process. And it's just overall been an incredibly useful tool for us. So I just wanted to display that for us a little bit here. All right, so now we are at technically the second step of our process. The first step is actually over at the intake station, which is across the river. That's actually pulling water from the river and sending it across to this point of the water treatment plant. And so what's happening here is raw water from the river is going in, and where these tubes are going into the piping there, that's where we dose all of our primary coagulants and pH control chemicals. So the things we're injecting at this stage right now, as the plant is running, is only aluminum sulfate or alum. Every so often we add caustic for, nope, poly's further off into the next chamber.
Oh, that's right. Yep.
So we only have alum going in here at this stage. Sometimes we have caustic going in for pH control. This blue mixer you see on top of the piping is called the rapid mixer, and it does exactly that. It mixes rapidly. So water's going through there. There's blades that are within the pipe turning, and they just make sure that all those chemicals are thoroughly mixed before they enter into the next part of the process. So this is...
So why is the intake on the other side of the river?
Right, good question, and that stumped me for a long time until I figured it out about a year or two ago. So if you look on a map of where the plant's located, we're located on a big bend of the Skagit River. And the idea is kind of water hydraulics was the reasoning, okay? So the intake is on the outside of the bend, and the plant is on the inside of the bend. And the reason why the intake's on the outside is because with inertia, with the water, it tends to, the water tends to more hug the outside of the river, and it scours it deeper on that side, down at the riverbed. And so then, therefore, we can take the intake pumps and we can have the intake deeper down in the river. And so that way we're able to operate even when the river gets to a low level. Now, on the other hand, we have the plant on this side, because with those same forces in the river that scour it out, if we have a flood event, knock on wood, it's more likely for that side of the dike to blow out than on the inside of the bend. And so therefore it would save the plant then in that case.
So what makes this job fun, exciting? What brings you back every day?
Well, I'll read mine. I'm trying to remember what I said here. So in our case, we're a special case at this water plant because we're one of the few in Western Washington that our source is a river. So for example, Bellingham, Skagit PUD, Everett, the two or three Seattle plants, they're all located on either a lake or a reservoir. And so with that, the water quality is pretty consistent for them. Whereas us, we're different because we're located on the Skagit River here. And, you know, a lot of the time, most of the time, it's pretty calm and mellow, especially this time of year in the summer. But the river can turn on a dime. And so really one of the things that I like about this job is that with my experience now and my confidence, when the river, when we have a dirty river event or a flood, it gets exciting because the conditions change and you've got to have your head on a swivel. That's one that really does it for me. You know, I also feel like this is one of those jobs where I go home at the end of the day knowing that I've actually done something that benefits other people, that I've actually contributed to society, if you will. And then I get a feeling of accomplishment, especially after I've become experienced and I've got confidence in what I'm doing. I get a sense of accomplishment that, you know, I've done a good job and I've gotten the job done. How about you? What do you think?
A big source of pride for me, which is, I guess, more specific to me and maybe one of our other operators as well, is that one of our wholesale customers is actually the town of LaConner, and I grew up in that town, and so I can go home at the end of the day saying that, hey, today I'm treated 10 million gallons of drinking water, and some of that is going back to the community that I actually grew up in. So having a direct impact on a community that I lived in for the early years of my life is pretty, I can take some pride in that, and that feels good at the end of the day.
Well, yeah, and I'll touch on that too. Another thing that I like is that we may be the City of Anacortes water treatment plant, but we don't just serve the City of Anacortes. I mean, we're definitely a regional water system, a regional water plant, and we've got some very important customers. We now sell, Oak Harbor gets all of their water from City of Anacortes, and that also includes NAS Whidbey, the Navy base in Whidbey Island, and so they operate with their water because of us. The two refineries that are located in Anacortes are our two biggest customers, wholesale customers, and they operate because of our water. And then, as Seth said, City of LaConner, We just recently, almost a year ago, we took over a water system on Fidalgo Island, the island Anacortes is on, that was using our water, but it was operated by Skagit PUD, and now we've taken that on as well. So we now directly serve the entire Fidalgo Island. So I take a lot of pride in that, the importance and the size of our wholesale customers.
I think another factor for me, the satisfaction I get from the job, is kind of in what I had said earlier. Hey, I just treated 10 million gallons of water today. You know, whether it's a slow day or an exciting day where you got a lot of stuff going on, at the end of the day, you're doing something that's tangible. You can go home at the end of the day saying, yes, I produce clean drinking water at adequate amounts for thousands of people every single day. So there's definitely the satisfaction of doing something.
One thing I've
Not
found
abstract.
interesting with some of the operators that I've known over the years that have been here or have moved on to other jobs is there's a couple different mindsets with operators. There's some that responsibility when they're in the operator's seat kind of gets to them and they overthink it a little bit and they get kind of nervous. And then there's others like us that responsibility that we have for public health and for the importance of our customers, I thrive on that. And I'm sure Seth does as well. You know, we thrive on that responsibility, and it just makes us do an even better job of treating water. And we just take it seriously because we thrive on that.
Yeah, and again, one more point of satisfaction at the end of the day is or even during your day, is you get to work with your hands. You're constantly doing things. There's different stuff every single day. Of course, like Cameron had mentioned earlier, that the river can be sort of flashy and change the water quality conditions really fast and often. And so having to adapt to an ever-changing sort of environment like that, or maybe there's maintenance going on, that part of your process is shut down, you got to work around that. There's a lot of variability throughout your.
It's hard to get bored.
Oh yeah,
it's definitely hard to get bored here.
Yeah, that's true.
Mm-hmm.
Yeah.
Now, do you think your camera's gonna be able to pick up any of the flock?
I don't know.
Oh, it's kind of tough with the grading, huh? Well, you could always try.
Go ahead.
All right, so here we're at step 3 of our water treatment process. This is really the meat and potatoes. This is where a lot of the legwork gets done. So the river water can look like chocolate milk, and then at the end of this process, it'll look like less chocolate milk, which is always a good thing. So what's going on here is basically at step 2, you saw our introduction of different chemicals. So we've got alum and caustic going in, and then we add our coag poly kind of down in this first region of step 3 here. And so what's happening in this process is there's a giant mixer that's below us here, and that's just keeping all this water agitated, keeping it moving around. And what's happening is this is the stage where all those flocks are first being formed and they're being matured. This is the maturation mixer. So those flocks are being formed and congealed together for effective settling over on this side of the train. So here on this side of the train, those flock have been formed and the water is coming up and over the weirs and then falling into these catchment basins. And so what the essential part of the treatment process is right here, where those flock are able to settle out of the water and provide clarified water that we can then send off to filtration and then get to our final drinking water products. So now we're at step 4 in the sand pump room. And so what's happening here is in step 3 is going on above our heads where that flocculation process is happening. And those flocks are settling down to the bottom of this treatment tank here. And all of that sludge that we've treated out of the water goes through this piping and into these pumps and then directed up and over and then down through hydrocyclones, which are basically these big cones that fling the sludge around and separate the sludge from the sand particles. And then that waste sludge can then be sent out to the lagoons, and then that waste product can be taken elsewhere and dealt with and managed.
Okay, let's talk money, can we?
Absolutely.
Sure.
What's a starting position pay?
So that one, I looked at our pay schedule for this year. Now that one's really subjective because that totally depends on the water system and the municipality. And a lot of the time, most of the water plants are unionized, and a lot of that is dependent on the union contract and what's been agreed to between the city or county or whoever, the operator of the water plant, and the union. Now in our case, I looked it up. According to our pay schedule for 2024, an operator in training will start out at $28.88 an hour for this year. That translates to $5,000 a month, $60,000 a year, and then your pay goes up with step raises every year, and then
that's obviously before any kind of deductions.
Yeah, that's gross. Yeah, definitely.
Yeah.
And you got the step raises every year, so you get usually a 3% raise after every year, and
Again, every municipality is going to be a little different.
Mm-hmm.
That percentage may be different.
some years we'll get a COLA, cost of living adjustment, of another few percent. And then when you get higher certifications, when you get bumped up into like a level 1, a level 2, a level 3, a level 4, you're going to get higher pay as well. So like I was saying when I introduced myself, I'm scheduled to take my level 4 next week, and assuming I pass that, yeah, right, I'll be getting a pay bump for that, above what I'm currently making.
Okay.
And again, that you could go talk to the city of Everett and it'll be completely different. Their pay will be completely different, but that's just the example for us.
All right.
All right. So this is step 5 of the treatment process, essentially. And this is really the most important step. Aside from maybe chlorination, I think personally this might be our most important step. Right here, we're on the bottom side of one of our filter bays. So this is filter number 8. All of the filtering is going on right past this wall here. The water is falling through the filter media. Excuse me. All of the water is falling through the filter media and being collected in this higher pipe that you see here. Both bays are feeding and then draining into this main piping that goes off into where we can send our water out into our storage tanks. This here is the flow control valve. This is in charge of how much water you want to send through the filter at any point. Obviously, we have limitations to how much flow rate we can put through at any single time. We can only run these filters for 96 hours straight. At that point, we have to backwash no matter what state they're in. But yeah, water is falling through, being collected through this piping and controlled, and then sent out to our other storage tanks where we add chlorine for disinfection. All right, and so here, at basically step 5 of our treatment process, we have the top side of the filter base. So as you saw down below, there was all the piping that collects the water that falls through these filter bays. But essentially water is coming in through this valve located below me here. The water flows in, goes through the troughs, and then overflows down into the actual filter bay itself. And I don't know if the camera can pick it up very well, but in person you can see the actual media down at the bottom of the filter. And so that's what's doing all the legwork in the filter bays. So the water's falling through that media and capturing any leftover sediment or pathogens or anything like that that could possibly get into the water.
So it really doesn't matter that stuff might fall out of the air onto this.
Absolutely
because it's
not.
going to go down through the filter.
Yep.
And then into a contained process.
Precisely, correct.
And how many of these filter bays do you have?
So we have 8 filters, and each filter has 2 bays on each side. They run in tandem with each other. So that's a total of 8 filters to answer the short answer.
And how many do you typically have online at any given time?
So previously, we had been running all 8 filters at the same exact flow rate, all running at the same time, which has been doing really well for us. But more recently, we've sort of adjusted our mindset on how we want to operate these filters, because we found that there was more efficiency to gain by operating them differently. So by efficiency, I mean as I said before down below, we can only run them for 96 hours straight. So if we run them for 96 hours, but they're not fully plugged up with sediment, then we haven't utilized the full capability of the filter. And so we're trying to mitigate that by turning a few of the filters off and increasing the flow through the remaining filters. And what that does is it gives you more throughput through less filters, increasing their efficiency during that 96-hour period. Yep.
All right. Covered all the questions.
Well, I think it would be good to talk about to go again in depth about the career path. I know we talked about the different positions at the water plant, but really there's a lot of options in this industry, and I've been to enough conferences now where I know that not only do you have the operator in training, you got the level 1, 2, 3, 4, instrument tech, lead operator, supervisor, plant manager, but if an operator chose to leave the actual active treatment aspect, like if let's say I decided I didn't want to be an operator anymore, I could use my knowledge that I have to stay in the industry and be relevant. And so there's a lot of different options. There's contract operators, and contract operators will either work for private contractors that operate water plants, or they will be just available to operate different plants as needed. The state actually has a program. The state of Washington has a program for contract operators. You could go into the private sector and still stay in this industry. So you could be a consultant. You could be an engineer. You could go into, let's say you go work for a pump company where you do sales and service. So you're still serving the industry. You're just not necessarily right there on the front line as an operator. Can you think of anything else that's in that industry?
There's a lot of small communities that have really, really tiny water treatment plants that serve, maybe 50 people or something like that.
Homeowner associations.
Exactly,
rural.
but you'd still need to be certified at whatever level is required for those. Mm-hmm. So there's positions open like that. As you said, there's a lot of other jobs in the peripheral of the industry, talking about like
good.
everything.
Yeah, I forgot to use that word. That's a good word for it. It's the peripheral.
Yeah.
Yep. Yeah, definitely the private sector.
So even if if you find out that you're not into operating water treatment plants, there's plenty of other jobs out there that deal with supply chains, supplying us with materials, or like you said, consultant work, where there's always trying to design different water treatment plants, or anybody's putting in new ones. They always want operator opinions. There's a lot of that too.
Also, I know that there's quite a few former operators that now work for the Department of Health, and then on the wastewater side, I believe there's a bunch of former operators, wastewater operators now work for the Department of Ecology. So that's another thing. You can stay in the public sector, but then go work for the state, and go and create the rules and the guidelines, and then enforce those and guide the water systems too. So there's really a lot of options.
Mm-hmm. Okay, cool. So now we're going to go, and you guys are going to show us how this place works.
Oh, do we have to?
Yeah, we do.
Okay, all right.
It's the reason I
We'll
can't.
do it. Yeah.
So, step 6 of our water treatment process. In this building behind us here, we have the low lift pump station. So that's taken all of our water that has gone through the filters and is now filtered water. Pumps basically bring that up from a storage tank that's in that building and pump it up and over through check valves, so you can't have any water flowing back into our process and contaminating the drinking water. So that water is pushed into these 2 storage tanks that we have on either side of the campus here. And each of these storage tanks is capable of holding 2 million gallons of water, so a total of 4 million gallons of water storage at this location out here. And so before the water enters into the tanks, we inject our chlorine dose. So that's where you saw the sodium hypochlorite out in the hypo room out there. So we inject our chlorine dose for disinfection, and that's a super, super tiny amount, but it's enough to keep the water from growing any bacteria or algae or any other sort of pathogens, and it makes sure that your water is going to be safe and clean to drink. And so that water flows through these tanks. There's a series of baffles to make sure it stays in there long enough to get good contact with the chlorine. And then that water then goes out of each tank, combined, and then sent into the high service pump building right over here. And so we got 5 high service pumps in there, and those are all, I think each one is about 1,000 horsepower. And what those are doing is they're sending water through two 32-inch water mains that go all the way out to the city of Anacortes. They also feed a few of the wholesale customers as they go out through the distribution system as well. But we use the high service pumps in here to fill our reservoirs that are out in town. And the reason those high service pumps are so large is because we need to send the water almost 12 miles and also 500 feet up in elevation to start filling those storage tanks that are in town for distribution in the city itself.
And in distribution, it's all gravity feed after it's in the tank?
Most of it is gravity fed. There are a few points in our system that have communities that are up on hilltops and things like that we have booster stations that aid. They're basically little pumps in line with the water mains, and those little pumps kind of aid in keeping that pressure and flow at the tops of those hills. But predominantly most of it is gravity fed, yes.
Okay, cool. So we'll go look at the pump station, yeah?
Yeah, sure.
But
We can head
won't
right
talk
on in
much
there.
because
It's going to be a loud room, yep.
All right.
All right, this is the high service pump room. Room for expansion. All right. So here we're in the ops room, the control room per se of the whole water treatment plant. This side is kind of where our maintenance staff like to seat themselves and like to mingle with the operators, make sure they know what's going on for the day. And then on this side we have our SCADA systems that actually run all of the digital systems that control the whole water treatment process. So every little step of the process throughout the entire way is completely controlled by these computers here. And you may have seen Cameron holding a little tablet as he was walking around giving part of the tour. That tablet is also connected to that SCADA system, which helps kind of give us some more range to walk around through the plant and still have control over the plant. But yeah, this is the ops room. Cameron, would you like to give a little history of the water treatment plant, maybe the previous water treatment plant as well?
Sure. Okay. So I mentioned before that this plant came online in 2013, and this replaced an old plant that we used to have down the hill that was demoed late last year and early this year, and then the pit was just filled in recently. And that previous plant came online in 1970, and it was run until we switched over to this plant in 2013. And the city of Anacortes has had the property here on the Skagit River since the 50s. Before that, the water source for Anacortes was Whistle Lake, and there was a plant located up there that was built back in the 20s. But like I said, we've been here since the 50s in one form or another.
It's been a pleasure showing you guys around the water treatment plant. Hopefully this is kind of giving you a good idea of like maybe what our process looks like. There's a lot of different styles of processes out there at many different locations throughout not only this state, but anywhere people need drinking water, obviously. But yeah, if you guys have any questions or want to come take a tour as well, if you got any groups out there that are dying to check the place out, we always take tours during weekdays at regular hours. So just call our numbers and see if we can get you squeezed in to do your own tour.
All right, so there we go. Tour of the Anacortes water plant. Don't forget, if you like this content, leave us a comment, do a sub.
Subscribe.
That's right.
Like and subscribe. Feel feed the algorithm.
Go ahead and smack that bell.
Need some help boosting this channel. So anyway, again, thanks for watching and see you next time.
Good evening and welcome to the 6 o'clock news. I'm your anchor, Cameron Fraser. Our top story for tonight. There, how's that?
Yeah, that sounds pretty
Yeah?
good.
Yeah,
I
okay.
like that camera.
Okay, cool.